everybody, this is me Vinu Venkatesh on behalf of Sai Education for Comparative Examinations. How are you all doing? So we're going to start our new topic today, arithmetic and geometric progression. We discussed this briefly in one of the previous lectures and we'll be doing it in detail this time. So I hope you've been following our lectures and I hope you're on track. So without further ado, let's start this chapter. So we talked about arithmetic and geometric progression, right? What is arithmetic progression? So arithmetic progression, if you remember, we said that it is a sequence of numbers where the difference between each of the terms is constant, okay? They have a common difference, right? And we learned two formulae there. One is to find the nth term, let it be Tn or An is equal to A or A1, which is the first term, plus n minus 1. That is the total number of terms n minus 1 into D, where D is the common difference. We talked about it, right? Let us start doing this problem, the problems. So here find the 10th term of 2, 6, 10, 14 and 18. So first and foremost, please identify whether this is an arithmetic progression. See if the difference between each of the consecutive terms is constant. So difference between 6 and 2 is 4, 10 and 6 is 4, 14 and 10 is 4, and 18 and 14 is also 4. So it is arithmetic progression. We can use this formula to get the nth term or the 10th term as 38. Okay. So relating to the first question is the second one. Find the sum of the n terms. Here again we have to use this formula. Sum n, Sn or S of S10 in this case would be n by 2. Open brackets 2a. A is the first term. You can call it A or A1 plus n minus 1 D. When you solve it, you'll find that the sum of the 10 terms from the series here given is 200. Okay. So number 3 and 4 are similar and straightforward to 1 and 2. So I'm not going to do it. You can try it yourself. Number 5, an important question. Okay. Find the sum of first 100 items of AP. AP is arithmetic progression of 1, 4, 6, 5, 11, 6. Okay. So n is equal to 100. Alright. Now let us see. There is some problem here. Look at the AP given. Difference between 4 and 1 is 3. But difference between 6 and 4 is 2. Difference between 5 and 6 is minus 1, right? 5 minus 6 is minus 1. Difference between 11 and 5 is 6. So this does not seem to be like an arithmetic progression. But the question says it is. So in this case, we have to divide the series into two sequences. One sequence which has a certain pattern and the other one different patterns. That is, there will be two arithmetic progressions. How do I know? Just look at what is common. See, 1 and 6, what is the difference? 5. 11 and 6, what is the difference? 5. So we can take this as one series. Okay, the number of terms here will be 50 because we know it's 100 items. The second arithmetic progression will be 4, 5, 6. Difference between 5 and 4 is 1, 6 and 5 is 1. So that will be your second arithmetic progression. So first what we have to do is okay, so let series number 1 or sequence 1 be this one. Let n be equal to 50. So what is the sum? N by 2, 2a. A is the series that we talked about, that is 4, 6, 5, that series. Okay, let me be specific. 4, 6, 5, that series. All right. So 2a plus n minus 1 into D. D is what? It is 1. So, sorry, it is 4, 5 and 6. So the sum of this series is 1, 4, 2, 5. Similarly, sequence 2 will be the series that we talked about. It will be 1, 6, 11, so on. So same formula. What will A be? It will be 1. What will what will be D? It is 5. So when you solve it, you'll get 6175 and total is the total of this series plus the total of this series, which is 7600, which is what even they got. So number 5 was very important. Please know how to do such questions. So be careful when you see some AP. If the question says it is an AP but it doesn't look like an AP, then look for a sequence with common difference and make that a sequence, and the remainder will be another sequence. So keep that in mind. Number 6 and 7 are similar and are also very important, different type of questions. Okay, let us do this. Find the sum of first 99 terms of this particular sequence. When you see such a question, first thing we have to add the numbers. Add this, and add this. So it's -4, -5, -6. They're saying 99 terms. Now one term is basically 3 numbers here, right? So we divide 99 by 3. So there are number of terms is 33. So n is equal to 33. Then simply you use the formula to find the sum, and then you'll get an answer of -660. Okay, this is the way of doing such a question. You'll only have to recognize that first you have to add this, right? Only these terms, not this, not the whole thing, only these 3 terms. And understand that 99 terms assumes that it counts like this, 1, 2, 3, 4, 5, 6. But we cannot take it that way because we are adding it. So these 3 terms become 1. Therefore you divide 99 divided by 3, right? See, it's like this, 3 terms become 1. Therefore 99 terms become how many terms? It becomes 99 divided by 3. So your n becomes 33. Alright, 7 is the same, so you can do it. Now number 8. Find the sum of all 2-digit numbers which are exactly divisible, which will be exactly divided by 9. Okay. So first we have to find the number of such numbers, right? You'll have to do some trial and error. What is the smallest 2-digit number which is divisible by 9? Let us start with number 10. Is it divisible by 9? No. Is 11 divisible by 9? No. So like that you'll have to do trial and error to find the smallest number which is 2-digit number which is divisible by 9. That is 18. 18 by 9 is equal to 2. Next, what is the largest 2-digit number? It is 99. Is it divisible by 9? It is, right? Then you simply start counting on your hands. How many numbers, 2-digit numbers, are divisible by 9? So it's 18. Just look at the multiples of 9. See, 9 into 2 is 18. 9 into 11 is 99. So how many multiples are there between 9 into 2 and 9 into 11? You have 9 into 2, 9 into 3, 9 into 4, 9 into 5, 9 into 6, 9 into 7, 9 into 8, 9 into 9, 9 into 10, 9 into 11. So there are basically 11 number of 2-digit numbers which are divisible by 9, right? So A1 is 18 and D is equal to 9. What is the difference between, say for example, 18 and what is the next 2-digit number divisible by 9? It is 27, right? What is the difference between 27 and 18? It is 9. So each of the terms have a difference of 9. Now simply use this formula and find the total to be 690. Yes, it will be 690. Oh, sorry. N is 10, not 11. So then your answer will change here. It is basically 9. Number 9. Find the sum of all 2-digit numbers which when divided by 9 leaves remainders 3. So this is an arithmetic progression. Okay. Here also we have to do trial and error. How? What is the smallest 2-digit number? It is 10. What is the largest 2-digit number? It is 99. So when you divide 10 by 9, what is the remainder? It is 1. Okay. What about 11? The remainder is 2. What about 12? The remainder is 3. So A or A1 becomes 12. Okay. What is the last or the largest 2-digit number which when divided by 9 gives you remainder 3? 99 is completely divisible by 9, so remainder is 0. What about 98? What is the remainder that you get? I think it's 8. Yes, 97, remainder is 7. 96, 6, 95 is 5, 94 is 4, 93, it is 3. So the largest number you get, you divide by 9 which gives you remainder 3. Largest 2-digit number is 93. Apply this formula and find the difference. Find n. You will find that n is equal to 10. You have 10 such terms. The difference will always be 9. To do that trial and error, you just have to take 2 or 3 sample numbers. Like after 12, start with number 13. What is the remainder? It is 4. So find the next two-digit number which is divisible by 9 and take that difference. That difference will be constant. Then once you find n, simply find the sum. You'll get a sum of 525. So they have given you a shortcut here. You can find the sum as n by 2 first term plus last term. So you can use this formula, but I prefer to go the traditional way so that you can understand better. So question number 9 was important, and number 10 is also important. It's a different type of a question. Let's take a look. The sum of second and fifth term of an arithmetic progression is 8, and that of the third and seventh term is 14. Find the 11th term. Okay, so T2 plus T5 is 8, right? And T2 can be written as A plus n minus 1D. So A, we don't know what A is, that is the first term, right? So let it be A. What is n in this case? It is just two terms, right? Because we are only looking at the second term. So second term is basically A1, the first term, plus n minus 1 into D. N is basically 2. So 2 minus 1 is 1 into D, right? Similarly, the fifth term can be written as A plus n minus 1, which is 4 into D. Why is n minus 1 4? Here n is 5 because we are looking at 5 terms. So when you add these, it is equal to 8 as per the question. So when you add it completely, you will get 2a plus 5d equals to 8. Okay. Similarly, third term plus seventh term is equal to 14, not 8. This is not 8, this is wrong. So third term can be written as a plus 3 minus 1 into d. 3 minus 1 is 2. When you add it to the seventh term, which is a plus 6d, that is 7 minus 1 into d, is equal to 14, not 8. This is a typo. When you add it, you'll get 2a plus 8d is equal to 14. Okay, so we have two simultaneous equations, 1 and 2. When you solve them together, you will get d as equal to 2 and a is equal to minus 1. Now simply find the 11th term. T11 is equal to a, which is minus 1, plus n minus 1. Here n is 11. N is 11 minus 1 into d, which is 2. What we got here, which is, so the 11th term is 19. I hope you're following. I hope this is clear. We have finished arithmetic progression. We will start geometric progression in the next class. Please keep practicing, and looking forward to seeing you in the next class. Take care and good luck.